Okay, welcome back. Hope everybody had a good weekend. Okay, so we're gonna do some material from the last chapter we're gonna cover in this course, which is chapter 10. And so we're gonna do a bunch of stuff on simulations and different types of probability distributions. All right, so I think you'll find some of this information and exercises pretty useful. So we're getting close to the end of the semester here. So remember, these two assignments are due today, just in the same spot on Blackboard. Okay, and so we'll do this one today. We're going to start chapter 10. We're going to do 3 or 4 exercises on chapter 10, and that'll be kind of the last material for the course. Okay, so intro to simulation models today. All right, so you can go to that section on Blackboard. Okay, and you can open up the intro to simulation models Word document. And the first one we're going to use is the ordering count, or sorry, the random numbers one. All right, so we're doing 3 exercises, but they're all pretty short. The first one will only take a few minutes. So for this one first, random numbers. And so for today's material, I'm going to try to introduce you to some different types of probability distributions, and then how we could use Excel to do some simple simulations. All right, so this stuff is going to be useful, and you can do it all in Excel. All right, so there's a nice little video on the shape of data. Um, you can take a look at that if you get a chance. All right, and so let me just first show you how to do kind of what we're doing, and we're going to do just a random numbers thing. So first exercise you want to do is just open up the random numbers Excel file. This one. Okay, open up that one. So it just looks like this. Okay, so I'm going to show you how to generate random numbers and then how to generate kind of a summary graph of your data. All right, so this is a quick one, but this is kind of what we're going to do. We're going to do some type of probability distribution, and then we'll find out how to make some summary of the data so you can see kind of what it looks like. Okay, so for this one, step 1, let's just generate 500 random numbers by entering the formula equals rand in cell A4 and then copy it down the whole range. All right, so just put that formula uh, in cell A4. Okay, so there's A4, so it just equals. Okay, equals rand, and then just open and close parentheses because we're not. Sometimes we put an argument in there, but for now we just want any random numbers. Okay, and without any specifications, when you put equals rand, it's going to give you any random number between 0 and 1. Okay, so you're probably not going to get 0.3 because it's random. There's essentially, a 1% chance it's going to be the same number. But just put that in there equals rand, and then let's copy that. Just copy the formula down all the way to A503. Okay, so just grab the bottom right corner of A4 and drag it down like this. Okay, so drag it all the way down to A503 because that's going to be 500 different random numbers. Okay, so you have equals rand in all the cells from A4 to A503. So that's 500 total. Okay, so your numbers will be different, but you should have a bunch of random numbers in this whole range. All right, so again, no one's going to have the same numbers if they're random. Okay, step 2. let's generate a histogram, okay, of bin versus count. So there's a little section of a little table with kind of a summaries. Okay, see that over here? So this shows um, the bins or the like the ranges. So this shows how many counts were between 0 and 0.1, how many counts were between 0 and 0.1 and 0.2, and so it breaks into quadrants, or I guess not quadrants because that'd be fours, but into sections of 10. So the lower 10, the next 10, all right? So all these groups count how many times an occurrence happened randomly, and your setup here will be the same, but your count's going to be different because it's random, okay? And so it looks like the 0.7 to 0.8 range gave me the most counts. And so to get a little summary of what you got, see it's hard to see just with looking at the table. You can make a little graph of bin versus count for step 2. So if you want to select C3 to C13, and then also select count, so hold down the control button, and then with the mouse or with your touchpad, you can select count. And so you want selected C3 to C13 and F3 to F13. Okay? And with those two selected, let's go ahead and do insert. Let's try recommended charts. And that's the one we want. So we want a clustered column. Hit OK. Okay, so see how that does. It shows you kind of the categories. All right, so the lower bin, or bin 1, you can see what the bins are. This is bin 1, this is bin 2, and it tells you how many counts you got into each. Okay, and you can, let's see, if you want, there's some other options to display. So since we don't have a lot of data, you can choose an option, I think, that gives you the actual count in the chart. So if you hit the chart and hit the little paintbrush thing for chart styles, you can choose an option that maybe one of these ones. Yeah, how about that one? All right, so that one, look how it displays the actual count in the different um, bins. Okay, and um, so again, I think if you don't have the shortcut there to get to chart styles, just click on the chart, and up here, let's see. Oh yeah, so if you're doing it with a Mac or somewhere up here, if you click on the chart, sorry, if you click on the chart and go up here, that's just the options are right here. So you can choose it just by looking at which one you want. All right, so whatever. Okay, and then maybe let's add a few labels. If you click on the chart, let's call this, or let's click on the plus sign, and let's click on axes titles, and let's take away um, chart title. Okay, so this over here is the count, and this is the bin. All right, and again, to do the same options with the Mac, click on the chart design, and then add chart element. You can do axes titles, and you can remove the chart title that way. Okay, so we got a nice little graph of bin versus count. And if you do anything or make any changes, like if you just hit the save button, or make any changes, see how I hit save and it does the simulations again. So anytime you save it or make any changes, it'll keep the same graph, but it'll update it based on the new simulation. So every time you save it or do something, it'll do it again. Okay, so you should have here a nice little graph of bin versus count, and so a nice way to see how you get the summaries different things randomly. Okay, so everybody got this one? Okay, so we have some other exercises, but this one was a quick one. This one's done. So the random numbers one is done. All you had to do was generate the random numbers equals rand here for 500 numbers, and go and look at the summaries of how many counts occurred in each, and make a nice little graph of those. Okay, so that's it for this one. All right, save this, and this is going to go into the discussion forum. Okay, so there's three total. So the first one goes in there, the random numbers into the intro to simulation models. Okay, so everybody's got this. So I'm going to close this one. All right, next one is we're going to look at a bunch of different probability distributions so you can kind of see what different types. If you take any statistics courses, you might recognize some of these types of distributions. And the point here is that if you see that your data follows a certain type of distribution, you can use that to set up the simulations. Okay, so next one you want to open up is probability distributions, which is this one. Okay, so it looks like this, where you've got five different tabs, and each tab has a little exercise for the different types of distribution. All right, so they're all quick little exercises, but it's a nice way to see what the data looks like if your um, project or whatever follows this type of distribution. So, okay, so each step is we're going to just make a little quick summary, or you're going to show that you're going to find the formulas of how to do the certain type of distribution, and then a little summary of that. Okay, so we're going to set up the distribution for each of these types, and then get a little summary, which is just basically the bar chart of category versus frequency. So step one is let's look at the uniform distribution. And for the uniform distribution, we'll generate 500 random numbers that follow a uniform distribution by modifying the general formula in B18 and copying it down the B column. Okay, so then we'll just create a histogram of category versus frequency. So the first one is uniform. Okay, so you're on your first tab, and the tabs give you a little summary of what the data is. So uniform distribution is continuous, symmetric, it's bounded in both directions, and it doesn't have to be positive or negative. And you can see that we're going to set it up so the minimum possible number is 50 and the max is 500. So it's going to be in between 50 and 500. Okay, and it doesn't have to be a whole number or anything. So it could be 50.1 or 55.6, right? So some number in between 50 and 100 is how we're going to set it up. And the formula or the modified formula we're going to use to do a normal distribution is just like this. Okay, so we're going to modify this normal formula right there, and we're going to use that to get, actually, what I like to do for these ones is let's make a couple range names, because then when we use the formula, it'll recognize the range names. Okay, so we haven't done this for a little while, but if you want to select this range, A10 to B11, and just do formulas, create from selection, left column, OK. And that'll give a range name for that, which is min val, and a range name for that, which is max val. And then we can just throw those in the formulas. Okay, so we're gonna use this formula and put it right here in B18. So the formula in B18 is equals, okay, min val, which you just set up a range name for, plus okay, so there's our formula, and you can see the exact formula we're referring to here. So it's equals min val plus parentheses max val minus min val times rand with the open and closed parentheses and nothing in that argument. So this is your formula. It looks just like that. If you hit enter, it's going to give you some random number in between 50 and 100. All right, it's not going to be the same, but it's going to be something. So again, it's equals min val plus parentheses max val minus min val close parentheses times rand. So as long as you set up those range names, it should give you something random. And every time you change something or hit enter, it's going to change it, but it's going to keep being a random number between 50 and 100. All right, so that's the qualification. And then you can just click on this formula, cell B18, double click the bottom right corner like this. And what that's going to do is apply that same um, uniform distribution formula with the appropriate boundaries all the way down for it should do 500 observations. Okay, so you should get a bunch of random numbers in between 50 and 100 for 500 different times. Okay, and then let's make a graph of category versus frequency so we can see how many times it occurred within these ranges. All right, how many times was it less than 55? How many times was it between 55 and 60? So it breaks it into little sections, and you can see that, and you can see kind of the distribution. So if you select this area, after you've done the calculations, so if you select E17 to F27, right, category and frequency, and then do insert, recommended charts, and we want that first one, clustered column, hit OK. All right, and you should get something like that. And again, you can change the format if you want to maybe. That's the one we did. How about any one of the ones that displays the actual count on it? All right, and then let's just we can make a title of category versus frequency. All right, so you got your graph, and again, when you click on the graph, you should have little options up here to change the style. You don't have to change it, but I like it since we don't have a lot going on. It tells you the actual count if you choose one of the options. And so this shows how many times it was less than 55, how many times it was 55 to 60, and so on. And if you save anything, or if you if you just hit like if I just do this, okay, if you hit enter or change anything, it's going to update. Or you save it. If you save it, it's going to redo it. But it should keep the same formulas and keep updating your category versus frequency chart like this. And so the point of the uniform distribution is it's an equal number of chance that it occurs in each of these boundaries. So it should be, I mean, you can see it's a little uneven, but if you keep doing it over and over, the idea is it's kind of going to be an equal number of occurrences in each of these categories. Okay, so we got this one, the category versus frequency. Everyone got the formulas and did it 500 times and put the little summary here of category versus frequency. Okay, next step is the next one. So click on the discrete tab, the next one. All right, and for step 2, let's generate 500 random numbers that follow a discrete distribution by again modifying the general formula and copying it down. And then let's again get a histogram of category versus frequency. Okay, so discrete tab, and these are the characteristics of a discrete. So it can be symmetric or skewed, so pretty much any shape. It's bounded in both directions, and it can be positive or negative. So you can see that we're kind of what we're doing here. So see the parameters, and so what we're doing, what the discrete distribution does is you put the most likely, or you put probabilities on what you think it's going to occur to simplify things. And so see what we've done is uh, the when we do the simulations, the outcome is either going to be 10, 15, 20, or 25. Those are the four chances, but there's different probabilities on each. So there's a 10% chance it's 10. There's a 30% chance it's 15. That's more likely. There's a 40% chance it's 20, and there's a 20% chance it's 25. So we've chosen the most likely occurrences and put probabilities on those occurrences. Okay, so that's what's going to happen. So you're going to get a bunch of 10s, 15, 20s, and 25s, but this is the most likely to occur, and so on. So that's the idea here. Okay, and let's see. We need, I think this needs to be called something. Or is this one already? Oh yeah, so I think this part's already set up, or the lookup table is already. All right, so if you click on this section, E11 to F14, you can see that it's already called lookup table. All right, so it's already been named. Okay, so just verify that when you click on this little section, E11 to F14, that it's called lookup table up in the name box, which it should be. Okay, so we've set it up like this, where we're going to use this to generate the outcomes based on the probabilities. So that's what we're doing here. Um, what you want to do is just put in, here's the general formula, all right? And let's put the first formula right there in B21, which is equals VLOOKUP, and then rand. Okay, then open and close parentheses. We're just modifying that formula you see there in row 17, and then comma, comma, lookup table, comma 2. So there's your formula, equals VLOOKUP, in the parentheses rand, open and close parentheses, comma, lookup table, comma 2. Okay, and see what it's doing? It's going to go to lookup table and then generate a random number, and then based on that random number, it's going to give you the value associated in the lookup table in column 2. Okay? So based on whatever random number, it's going to assign, if it's a random number less than 1, it's going to give you 10. If it's a random number between um, 0.1 and 0.4, or sorry. So let's see how does this work. So there's a 10% chance it's, yeah. So if it's less than 0.1, it's going to be 10. If it is between 0.1 and 0.4, it's going to give you 15, right? So based on the random number you get, it's going to give you the value right there. See the column, the number 2, the indicator, right here. So it's going to give you one of these 4 things. Okay, so based on your random number, you either should have a 10, a 15, a 20, or a 25 right here. Okay, so it doesn't have to be 20, but you're going to get one of these 4 values. If you didn't get one of these 4 values, then something's wrong. Okay, now let's copy the formula down. So if you got this formula here, go ahead and just click on B21 and double click the bottom right corner like that and apply that same formula 500 times. Okay, so you should, based on the way we set this up, get 500 simulations and a bunch of different 10s, 15, 20s, and 25. So nothing else can happen except for those 4 based on their probabilities. Okay, and then we can get a summary of what happened, and you probably see that the ones that had a higher probability occurred more. All right, there's a chance that it didn't, but it's likely. So if you click select E20 to F24, like this, all the categories and all the frequencies after you did the simulations, and let's do insert, recommended charts, clustered column, okay, and you can change the format if you want. I usually like this one or this one. There we go. And we can call this category versus frequency. Okay, so every time you change it or save it, it's going to update. But you can see that, so the number of times it was 10 was 52. The number of times it was 15 was 160. The number of times it hit 20 was 186. And the number of times it hit 25 was 102. And you can see most likely you're going to get the most 20s because there's a 40% chance of that. The second most hit should most likely is going to be 15, and so on. So you can see that it's random, but there's probabilities. All right, so we got that one there. Okay, everybody got this one. The 500 simulations for the discrete distribution and the graph here to show the summary. Yep. All right, and again, every time you save it or hit something, it's going to update it, but it should keep the same graph. Okay, so we got the uniform distribution. We got the discrete distribution. The next one is discrete uniform. Okay, so we know what's happening. We're going to generate 500 random numbers that follow a discrete uniform distribution by modifying the formula and make a little graph of category versus frequency. Okay, so click on the discrete uniform tab. Okay, what are we doing? So here are the characteristics. Discrete uniform, it's discrete, symmetric, it's bounded in both directions, it doesn't have to be positive, and the point that um, so this discrete means that it's going to be a whole number. Okay, so the minimum occurrence is the way we set it up, 1, and the max is 20. Okay, so we're going to get random numbers between 1 and 20 that are whole numbers. So you only have, it can either be 1, 2, 3, 4, all the way up to 20, but nothing else. So we've set the min at 1, and we've set the max at 20. And if you want to make range names here, it'll make your formula a little bit easier to follow. If you just click on these cells, A10 to just B11, and do formulas, create from selection, left column, OK. All right, so that should be called min val, and that should be called max val. Okay, and let's modify this formula using those range names in B18. So in B18, just going to put in this formula right there, equals, okay, equals ran between min val and max val. And make sure that um, you can type, usually you just shortcut the range names, but because we made a range name of the same on a different tab, make sure it's choosing the right ones, right? So make sure it's not choosing these ones over on the uniform. So see how it's actually choosing these ones. So it should be equals ran between min val comma max val. So it's going to be some random number um, between 1 and 20. Okay, and then click on B18, double click the bottom right corner. All right, and you're going to get 500 random numbers, all numbers between 1 and 20. Okay, and then let's see how many times we got a hit for each number. So if you click all of this, uh, E17 to F37, all the categories and all the frequencies, and do insert recommended charts. Let's do that one, the clustered column, okay.
Wait, Professor,
Yes.
um, for the data for histogram, like I got like 91. Like it's not between like 1 and 20. That makes sense.
For this one?
Yeah.
Oh, okay, so all right, so let's just see. So your formula for the first one in B18 should be equals ran between min val and max val. And when you click on your formula, does it show that it's choosing that and that?
Oh, it's not choosing the min and max for some reason.
Well, it's okay. So if the range names didn't work, just type in the number. So let's do this. Modify your formula to equals. Okay, so if you this will do the same thing if you do equals ran between, and then in the parentheses 1 comma 20. Okay, so just do that and hit enter. Did that work?
Yeah, thank you.
Okay, and then yeah, just if that worked, just double click the bottom right corner and that should apply it down 500 times. So that's, yeah, that'll do the same exact thing. Okay, if you didn't get the range names, just specify the numbers there. All right, and that should work. Um, and then after you do that and do the 500 simulations, you want to select category and frequency and make a, a chart here. All right, and so we've got this. If you want, you can change the option to maybe that one. Okay, and we can call this chart category versus frequency. Okay, and again, if you save anything or hit enter or save, it's going to change it, but you should get a chart here that shows how many times in the 500 simulations you got one, and so on. So it's random, but it looks like I got the most 16s, but if you do it again, All right, it's gonna depend. So there's just there's a likely chance that it occurs in any of these numbers, but if you do it enough times, this will probably be flat. So if you do this like a million times, you're probably going to get um, close to the same number of hits in each category. Okay. Uh, okay, so we got this one. We got our 500 discrete uniform simulations here, and we got the summary of category versus frequency right here. All right, so there's that. Okay, everybody's got this one. Okay. Okay, next one is something you're probably very familiar with, is the normal distribution. All right, also known as a bell curve. So let's set up this one and make a little graph of that, see what it looks like. Okay, next tab is normal. Okay, so you know a normal distribution is continuous, it's bell-shaped, it's unbounded in both directions, and it can be positive or negative. So the way the normal distribution works is you have a mean and you have standard deviations from the mean. So there's going to be a bell curve that centers around the mean, but it can still occur outside the mean, but it's going to be less likely. So the bell curve is going to mount around the mean of 100, but it can have deviations of 10 away from the mean. So we're going to have a normal distribution around 100. Okay, and again, let's maybe specify our uh, range names for the parameters. So if you want to select A10 and B11 like that and do formulas, create from selection, left column, okay, that's mean. That's STDEV. Okay, so let's set up a normal distribution with a mean of 100 and a standard deviation of 10. All right, so let's specify this formula right there in B18. Okay, so the formula in B18 is equals. All right, make sure it's that one, norm, INV, this one. And then probability is uh, random. Okay, and then comma mean, we made a range name there. Okay, so there's your formula, equals norm, INV, which is the normal distribution function, and then in the parentheses, rand, open and close parentheses, comma mean, comma STDV. And you can see that these ones are selecting the range name. So you should get some number um, around 100. So again, it's equals norm, INV, and then rand, open and close parentheses, comma mean. Okay, make sure it selects the range name, or you can just type in 100, and comma STDV, which should select that, or you can just type in 10. Okay, so we're gonna apply that uh, general normal distribution formula all the way down. Okay, so click on B18, double click the bottom right corner, and there we go. So you should get 500 observations of a normal distribution around 100. Okay, and then let's make a graph of, again, category versus frequency. Okay, so select E17 to F31, And let's do our graph. Insert, recommended charts, clustered column. Okay. All right, and then let's see if we can change the. Actually, this one, I'm just gonna leave it how it is because I just want to see the bell curve kind of thing. So I'll change the title to category versus frequency. Okay, and so you can call it category versus frequency, and then this is the normal distribution. Okay, so you can see that it should be somewhat of a bell curve, right? So you should see it's not going to be exactly like this, but it's going to fluctuate around 100, where you're going to have probably the most occurrences in this range, 100 to 105, 95 to 100, and 105 to 110, and then it can occur outside the range, but not as likely. So I have nothing less than 70 and only one bigger than 130. So you can see the bell curve situation where it can occur outside the bell curve or the tails, but it's much less likely. Okay, so did we get that one? We got the normal distribution formula. We did it 500 times, and we got the graph, which again, when you do your graph, it should look somewhat like a bell curve. Okay, last one for this exercise, the binomial. So if you go, okay, last step in this exercise is let's generate 500 random numbers that follow a binomial distribution and make a little summary of that. Okay, last one is binomial. All right, and this is discrete, symmetric or skewed, bounded by zero, and it's bounded by the trials, and it's non-negative. And so what we're doing here is let's see. So the parameters, there's 170 trials, and there's an 80% chance of success. So you're going to give um, each of these is going to tell you how many times it was a success in 170 trials. Okay, and so if you're trying to get like a specific, um, if you have a specific number of trials or observations, and you're trying to see how many times a certain outcome occurred, right? Then you can do this. So this can be used for like elections or yes or no things. If there's a probability on some outcome, you can do a simulation of that. Okay, so if we make range names, it'll make our general formula easier. Okay, you can select A10 to B11, and then formulas, create from selection, left column, okay. So that is N trials, and that is P success. So this is the number of trials, and this is the probability of success. All right, that's all we're doing. Okay, let's modify this formula and put it right there in B18 equals. Okay, crit, that one, crit binom, that's the binomial distribution. And then N trials, comma, P success. Okay, comma ran. So you can see that there it is. So equals crit binom, N trials, comma P success, comma ran, and make sure you have the extra parenthesis there. Okay, so see it's equals crit binom. And then the trials are the range name n trials, which are 170. The probability, we range name that as p success, which is 80%. And it's random, so put the random function there and make sure you have that uh, the random with the open and closed parentheses and the extra parenthesis on the end. Okay, so it's going to be some number between 0 and 170, and there's an 80% chance of success in 170 trials. So it's going to be something around, yeah, I mean, it's going to be somewhere in the 100 to 150 range, or 100 to 170 range. Okay, so we got that formula there. And let's go ahead and click on B18 and double click the bottom right corner like this. Okay, apply that same formula down for 500 observations. Okay, so you should get a bunch of numbers uh, in the 100s, so it's going to be less than 170, but somewhere around there. Okay, and then let's see what this distribution looks like if you want to select a graph or select category and frequency. So E17 to F55, right? This whole area. Okay, so E17 to F55. And when you have category and frequency selected, you can make a graph. Okay, insert recommended charts. We want this one, the clustered column. Hit OK. All right, and then we don't need to put the labels because there's too many bars, but we can call this category versus frequency. Okay, and this is the binomial. So you can see it's kind of like a bell curve where there's an 80% chance it occurs. So this is based on 170 trials, there's an 80% chance of it being 170. So that means it's going to fluctuate around 80% of 170, which is somewhere like 134, 135, 136. So it's most likely bell curve around here. You can still have, but you can see that the number that if it only succeeded uh, 119 times, it only happened once, and nothing happened below 117. Okay, and nothing happened above 154. So based on the probability of 80% of 170, this is the number of successes in 170 trials. So you should see somewhat of a bell curve type situation when you do the graph here. Okay, it's actually a little bit steeper, so it's more like a, yeah. All right, so we got this one. We got all the binomial distribution simulations and the graph here of category versus frequency. Nice little steep bell curve. All right, so we're done with this exercise. So we got the uniform, we got the discrete, we got the discrete uniform, we got the normal, and we got the binomial. All right, so you got those five. All right, so I think we're done with this one. Okay, we still got one more exercise to do, but the probability distributions exercise is done. So you can put that, you can save that. That goes. Okay, that goes here in the intro to simulation model. So we have three Excel files here. We have the random numbers, which we're done with. We have the probability distributions, which we're now done with, and then we have one more. Okay, so everyone's done with this one. I can close here. Okay. All right, so last one you want to open up is the ordering calendars flaw of averages, this one. Okay, so now we're going to do example 10.1, which is ordering calendars at Walton's bookstore. And you got that Excel file opened up, which is the ordering calendars flaw of averages. Okay, I think I have a little description on this one. Okay, so this is for us example 10.1, ordering calendars at Walton's bookstore. So in August, Walton Bookstore must decide how many of next year's nature calendars to order. Well, if that was now, probably zero, but when this we can do this exercise. So each calendar costs the bookstore $7.50 and sells for $10. After February 1st, all unsold calendars will be returned to the publisher at a refund of $2.50. And Walton believes that the number of calendars it can sell by February follows the probability distribution shown in Table 11. Okay, and so there's different probabilities that demand can be these things. And Walton wants to develop a simulation model to help it decide how many calendars to order. So we're going to use the demand and probability distribution chart to set up a model here. All right, so you can see when you go to your spreadsheet for the ordering calendars, there's one tab for the deterministic model and another tab for the simulation model. And basically what we're going to do is the first one, we're just going to choose the average and see what the profit is. And then we're going to do a simulation based on the probability distributions and see if that's a better outcome, which is going to be because if you know that your uh, demand follows a normal distribution, you want to use that information if you can to do a simulation and not just choose the average. Okay, so the first tab, deterministic model, it's simple here. We got it costs $7.50 per book per calendar. We sell that at $10, and if we don't sell it, we get a refund of $2.50. Okay, average demand is 200. So we're going to order the average and see if that works. And then we'll compare that to the simulation we're going to do in the next step. Okay, so step one, oh, so we haven't done this in a while, but we can set up the inputs and the decision variables and the objectives. So remember doing this. Okay, so the inputs are the cost data, so you can color those things light blue. Um, Demand is uncertain, so I think the color for uncertain things was like the green, light green. We're deciding this, so that's the decision variable, that's light red. And profit is our objective we're trying to maximize, so cell F16 is the objective, which is the highlight yellow color. Okay, step two, just put these formulas in B16 to F16 to calculate the cost, the revenue, the cost, and the profit. All right, and then let's see what it is. So starting in F16, we're putting these 5 formulas in. All right, so let's start doing that. All right, this one's already done, equals B9. Our average demand is 200. Okay, next formula is revenue. So in C16, put in that second formula in step 2, which is equals. Okay, equals B5 times min B9 comma B12. So what this is doing is our revenue uh, is the unit price, the selling price times the minimum. So if we order more than demand, we can only sell what demand is. And so this is the same type of logic we did from the bookstore before, where if if these are equal, then we sell 200. But if we order too many, we can only sell what demand is. And if we don't hit demand, we can only sell what we ordered. So the minimum of the two times the unit price is the revenue. Okay, so 200 times 10 is 2,000. Cost, next formula in D16 equals B4 times B12. So each calendar costs 750. If we order 200, then 750 times 200 is 1,500. Okay, and remember we get a refund of 250 per calendar if we order too many. So the refund is going to be 0, but to specify it is in E16 equals. Okay, equals B6 times max, B12 minus B9, comma 0. Okay, so what this is doing is we're getting a refund of B6, which is 250. If we order more, if the difference between what we order and what demand is positive, so if we order too many, we get a refund of 250 per calendar. If we don't, we get 0. And see, since they're both equal, that number is going to be 0, so we get nothing. But if we did order too many, we would get a refund of 250 per calendar. And then profit is just revenue minus cost. So in the yellow cell, F16 equals equals C16 minus D16 plus E16. So this is just profit is revenue minus cost, and then if we did get a refund, we would add that. That's like a credit. So profit's revenue minus cost plus refund, and you should get now that your profit, based on this simple model, is 500.
Wait, Professor.
Yes.
Um, Below refund, it for me it just says like field, like it doesn't say 0. Yes.
Oh, this one? Oh,
Yeah.
so let's double check your formula. So it should say equals B6 times max function, and then in parentheses, B12 minus B9, comma 0, and then close parentheses. So is that what your formula is there?
Yeah.
And when you hit enter, it says not 0?
Yeah. It just says field.
Uh, okay, so when you click on it, do you see how it like is your B6 that number, and your B12 that number, and your B9 that number? Like, are all the numbers being highlighted the same?
Yeah.
Okay, well, you want to post it? I'll take a look.
Yeah.
Okay. Okay, so everyone else got 500 here. So we'll do the simulation model in a second, but we got our demand is going to be, we're just using the average. All right, and then we get our revenue, our costs, and our refund, and our profit is 500 based on ordering just the average. Okay, so this is doing it without a simulation. Next, we're going to use the information we have, which is the normal distribution with probabilities, to see if we can do a better demand model by doing a simulation. All right, so let's see what's interesting. I think so. It looks like there's just a period instead of a comma, so it should be equals B6 times max, and then B12 minus B9, comma 0. Okay, and that should do it. So just it looks like you just typed in Raymond actually a period right there instead of a comma. So if you change that to a comma and hit enter, and then just do the rest of it, that should do it.
Oh, okay. Sorry, thank you.
Yep. Okay, no problem. And then your profit formula is C16 minus D16 plus E16, like that last one in step 2. Okay, that work?
Yeah, thank you.
All right, you're welcome. Okay, so we've done the deterministic model. Now if you click on the second tab for the simulation, let's do the same exercise, but with the information we have, which is that demand follows a normal distribution around 200 with a standard deviation of 40. So if you have that information, you want to use that to get a better model. In this case, we can do a bunch of simulations, and we want to see if actually ordering something different than the average is a better option. Okay, so click on the simulation tab and step 3. All right, so let's again set up our inputs, uncertain quantities, decision variables, and objectives for the simulation tab. Okay, so the cost data are all inputs. Okay, so those things are light blue. B4 to B6. Demand is random, and let's make that uh, light green. Okay, this is our decision variable, so that's light red. B12. Okay, and profit is the objective, which is F16, so that's the objective, which is highlight yellow. Okay, so step 4 is let's calculate the random variable by using a normal distribution around 200 with standard deviation of 40. So put that formula in B9. Okay, so in B9, which should be the green cell, equals equals norm INV, and then in parentheses, rand, okay, open and close parentheses, then comma 200, comma 40, like that. So there's our formula. Okay, what is it? Okay, equals norm INV, and then in parentheses rand, open and close parentheses, comma 200 is the mean, and then comma 40 is the standard deviation. All right, so it should give you something around 200. Well, in the range. Okay, and so you can't order a fraction of a calendar, so if you click on this cell, B9, and just go up to the shortcut and take away the decimals. All right, so just make it a whole number, and the shortcut under the Home tab is right there. It should say decrease decimal. So you can just hit that until it's 0. Okay, now we're going to put these formulas in B16 to F16. All right, and then we'll do a simulation and a graph, but this part first. So starting in B16, that goes there, and then this is like B17, or sorry, C16 all the way to F16. So these numbers, these formulas, are going in the range respectively, B16 to F16. Okay, so let's do that. Okay, B16 equals, okay, that same formula, norm INV, and then same thing, so rand, then 240. Okay, so in B16, it's equals norm INV, then in parentheses, rand, open and close parentheses, comma 200, comma 40, close parentheses, so it's a normal distribution with probability random. Uh, Mean is 200 and standard deviation is 40. All right, again, if you can remove the decimals, it's going to make the simulations a lot easier to see. So click on that cell B16, and then if you see the shortcut under Home tab, this one, decrease decimal, just hit that a couple times, or I guess 4 times. Okay, next formula in step 5 is C16, so revenue equals. Oh, okay, equals $B, $5 times min, and then in parentheses B16, comma $B, $12. All right, so the same thing we did before, but now we have dollar signs because we're going to do a bunch of simulations. So your revenue is the minimum of demand and order quantity, because if you don't order enough, you can only sell the ones you ordered, and if demand is too low, you can only sell what demand is. So the min of these two times 10 is going to be your revenue. So make sure you got equals $B, $5 times min, and then in parentheses B16, comma $B, $12, close parentheses. Cost is in D16 equals. Okay, equals $B $4 times $B $12. Okay, so cost is always the order quantity times 750. Refund. Okay, if we order too many, we get a refund of 250 per calendar. So in E16 equals. Okay, equals equals $B $6 times max, and then in the parentheses B $B $12 minus B16 comma 0. All right, so again, what's happening with this one is if we order too many, we can sell the difference, the extra, back, and we get a refund of 250 per calendar. So if this were less, or sorry, if this were more than this, we could sell the rest back. Okay, and then profit is just revenue minus cost plus refund if we get it. So in the yellow cell, F16 equals. Okay, equals C16 minus D16 plus E16. So equals revenue minus cost plus refund. Oh, sorry, I missed the chat thing. So, not sure what equals INT.
It just makes it the whole number. That's okay. It
Oh,
works.
okay. Oh, for which one?
For the when we used norm INV and we got decimals, I just made it integer instead of removing the
Oh,
decimal.
yeah, that works
Yeah.
as long as, yeah, okay, no problem. Okay, thanks. Yeah,
Thanks.
sorry, I didn't know what to. Oh, you just, okay, I see what you did. Yeah, that works. Okay, so we got our demand function here, which is the normal distribution with the mean of 200 and the standard deviation of 40. We get our revenue, which is based on whichever of these is the lowest times 10. We get our cost, which is always order quantity times 750, and we get a refund if we order too many. Okay, and then profit is revenue minus cost plus refund. Okay, so we got these formulas here. Your numbers will be different because it's based on a random simulation, but the uh, the formula should be the same. Okay, so last step is we're going to number our simulations 1 to 500 and A16 to A515. Let's do that first. Okay, so this is essentially simulation 1. So just put a 1 here in A16, and let's put a 2 here in A17. Okay, and we just want to count from 1 to 500 to do 500 different simulations. So if you've got 1 and 2, you can select those, A16 to A17, and just grab the bottom right corner and count up all the way from 1 to 500 like this. Okay, so you want to number 1 to 500 in that range, starting in A16, going all the way to A515. So just use the Excel shortcut to count up to 500. So you should have 1 to 500 starting in A16 going all the way to A515. Okay, so did we get that part there? We're numbering the simulations we're about to do. So this should just count up to 500, all right? Okay, then we're going to copy the formula in B16 all the way down, and then we're going to copy the other ones. Okay, so for demand, let's click on B16. Okay, we're going to apply the demand function, or the demand formula, all the way down for 500 different simulations. So click on your formula, click on B16, and if you got the numbers here, double click the bottom right corner of B16 like that. Oops. Okay, and that should do the demand formula 500 times. Okay, so you should get demands that are around a normal distribution of 200. Okay, and then let's copy and paste all the monetary things, the revenue, cost, refund, and profit. So if you want to select C16 to F16, and first if you want to take away a couple decimals, we don't need those right now, or we don't, it'll be easier to see if you just hit decrease decimal a few times. Okay, and then what we're going to do now is apply all these formulas at the same time down the 500 simulations. So when you have selected C16 to F16, just double click the bottom right corner like that. And what that's going to do is apply the revenue, cost, and refund, and then the associated profit for each of the simulations based on the random demand that follows a normal distribution around 200. Okay, so you should have 500 demands, revenues, cost is always the same, refunds, and profits. Okay, and sometimes, look, if demand is way too low, we lose money. Okay, so did this work? Did we get the simulations, all the demands, all the revenues, all the costs, all the refunds, and then the profits? So you should have 500 simulations that calculate a profit based on the demand, the random demand, but around a mean distribution of 200.
Professor, could I please see the revenue formula again?
Yeah, here it is. So the one you want to just look at is the one in C16. So it should be equals $B $5 times min, and then in the parentheses B16, comma $B $12, and then close parentheses.
Okay,
Yeah,
I
so
got it. Thank you.
okay, and then apply that down. Yeah, and so just make sure your dollar signs are for that one and that one, but you want your demand to move when you do the different simulations. Okay. Okay, so everyone else good here? We got all our simulations that lead up to profit for 500 different simulations. Okay, very last step is let's create a graph of demand versus profit, and let's see what that looks like. Okay, so let's go ahead and select all the demand column and all the profit column. So we're going to select this one and this one. And to do that, let's first do demand. So to select the whole range, since it's a big range, the shortcut is click on demand, B15, and you can click on Shift Control down. We'll select everything. So you want selected. Everything here from B15 to B515. All right, and then you also want to select profit. So if you hold down the control button and choose the whole profit range like this, all right, so you got to use the mouse or the touchpad, and you got to use the control button. But first select demand, and then hold down control, and then select profit. So you got both these ranges selected, which is B15 to B515 and F15 to F515. So the whole demand column and the whole profit column. And then let's make a graph of this selection. So insert, sorry, yeah, insert tab, then recommended charts. Then this one looks like the one we want. Histogram. Okay. Yeah. And then we can call this demand versus profit. Okay, so did we get that? Did we get all the demand selected, all the profit simulation selected, and then a nice little graph? So if you did it correctly, you should see this little, it should look like a normal distribution. So you can see that we get the most hits around the average of 200, and then you can still get hits around, in the tails, but it's less likely. Okay, so if you did this demand versus profit histogram, you should get something of a normal distribution, kind of looking like this. All right, so did we get that? Okay, so everybody's good on this one. All right, so we're done. We're done with this one. Okay, so if you got everything up to the um, normal distribution graph, we're done with the exercise 10.1. Okay, so we'll use some more of this type of logic in the next exercises, but we learned a lot about different distributions and how you can use simulations to get a better result. And so what we saw here, what we determined here, is that you don't always want to order the average. Okay, so it looks like depending on your graph, ordering something less than the average between like 175 and 193 is better than just ordering the average of 200. Okay, so this one's done. We got the deterministic model, the simulation model. You can save that. Okay,
But
that
sir,
complete.
everyone's graph will have different answers, right?
Well, yeah, exactly. Yeah, so it's going to be, yeah, so even if you hit save, like if you hit the save button, it's going to change it a little bit. Or if it, let's see, I hit the, all right, so see how if I do things, it changes it? Okay, yeah.
Yeah.
So it's going to be a little bit different. It might, but it should be somewhat of a bell curve. So it doesn't, actually now it looks, So it should look something like this. It's okay if it's, you know, like that or like that. You know, based on your randomness, it's going to be different. But yeah, it's going to be a little bit different, but it should resemble a bell curve. Okay, so we got this one. Can save that. All right, and we're done with this one. So you want to put your completed random numbers, your completed probability distributions, and your completed ordering calendars, flop averages. Those 3 Excel files go here. Okay, so just either make 3 posts or you can reply a couple times, but post those 3, and that's it for the uh, intro to simulations exercise. So those 3 are due next Monday. And then again, make sure that you get this one, example 14.7, 14.8, and the stock market forecasting. If you're going to do those 2, those are both due today, those 2. And then this one's due next Monday that we just did with the 3 Excel files, and then we'll do this one on Wednesday. Okay, so we're almost out of time, but that's it for today. And so thank you all for joining, and have a good rest of your week. And I'll see you Wednesday morning, and thanks.
See you, Professor.
Thank you.
Thank you.